Hey Math Nines, and welcome to our discussion today, 7.2, which is going to be discussing scale diagrams and reductions. Last day we talked about enlargements and how they all have a scale factor of greater than 1 or greater than 100%. Today we're going to be dealing with diagrams that have scaling of under 1 or under 100%. Just a reminder that when you create a scale factor on a diagram, you're always dealing with the scale length divided by the actual or the original length of the object. So for example, here we've got our original object, which this isn't the scale, it is the scale, but it's just not the actual size of it. In this case, we have a rectangle that's being represented as having a length of 3.6 meters. We are going to make a reduction of that down to 1.2 meters. Can you calculate for me the scale factor of that image? Give you a couple seconds. You can pause me if you need to. Here's the answer. Well, the scale length is actually 1.2 because we've made it smaller, and our actual original length is 3.6. So that's going to be 1.2 over 3.6, which reduces down to actually 1 over 3, which is basically 33.3%. So I could either have it as 1/3, I could have it as a decimal value of 0.3 repeating, or I could have it listed as a scale factor of 33.3%. Again, we know that's a reduction because the percentage is either under 100, or the number or the fraction or the decimal or the fraction is going to be below a value of 1.0. All right, now that I've discussed that, let's give you an example of how you would actually scale up or scale down an actual image. Here's a graph paper that's below. Again, my handwritten or my hand-drawn graph paper. If you've got graph paper at home, obviously going to make this a lot easier for you to draw these diagrams. So if you've got graph paper, certainly grab it right now. You can pause me if you need to grab some of this before you get started with this. Right here, I've got a shape that's basically drawn down. What I like to draw now is I like to draw a 2/3 scale factor of this original diagram. So we're gonna scale this down. We're gonna reduce it down here on the lower section of the graph paper. Again, if you can't really see it at home, here are your dots just to see where your corners are. And you've got a diagonal line that's sort of represented there, straight, straight, and straight to there. Just so you know, we've got 3, well, you can count them. Give us pause that video. You can pretty much see, I can see it very clearly now. So that should be able to give you an idea of how you're going to scale this down. So you need to do a 2/3 reduction of this. How are you going to tackle that? So pause the video right now, give it a shot, and I'm going to come back and let you know how you're going to actually do it. All right. So here's how we do it. We know that our scale factor, again, is going to be 2 over 3. Now, the good news about this is we've been very nice that all of our sides are multiples of 3. We've got a side length here of 3. We've got a side length here of 3. We've got a side length here of 6. And we have a diagonal line here across 3 diagonal blocks on the grid paper. I'm going to ignore the diagonal line. If I do everything else right, the diagonal line will kind of come into play at the end of this. But I know that for every length of 3 that I have, I'm going to reduce each length of 3 down to 2 because the scale factor is, this is the original. So the original length would be 3s, and then I'm going to reduce anything that's a length of 3 down to a length of 2 because this is the original length. That's going to be the scaled length down to 2 if my scale factor is 2/3. So I'm going to start off with my top corner, and I'm going to have that as my starting point. And I'm going to basically, I have a length of 3 here, so I'm going to reduce that down to 2. So I'm just going to use 2 blocks there. That becomes my first side of my shape, of my quadrilateral, whatever you want to call it. This is a length of 1, 2, 3, 4, 5, 6. So I'm going to have 6. For every 3, there's 2. So I'm going to basically take 6 and I can multiply it by 2/3. It's going to give me 12 over 3, which is going to give me a value of 4. So 4 is how many I want here. There's my bottom length. On the top, I've got 3 as well. That's going to reduce down to 2. So we'll reduce that down to 2. And then we're going to just fill in our little diagonal line there as well. As you can see, there is my scaled down version. If you can't really see the top one very well, let me just kind of draw that in for you right now. Might make it a little bit more visual at home, kind of like that. You can definitely see that we have scaled down that image, but that represents essentially a 2/3 scaled down version of the quadrilateral that was written above. And again, if you need to check it out, here on the graph paper, here on my slide, I'm basically showing you all the calculations with little animations or whatever. You can certainly do this. Look at that at home to kind of see that final represented quadrilateral on that piece of graph paper. All right, let's take a look at a kind of a sample question here as to how this would actually play out. What I've got here on this diagram is a top view of a pickup truck. So this would be sort of the hood. This would be the top of the not the box, but I guess where the steering wheel and all that is located, and the back of the pickup truck is over there. We're looking at sort of a top view of this pickup truck. The scale is 1 to 50, so we're doing a scaled down version that would essentially be 1/50 would be if you ever see that 1:50, it's the same as 1/50, or that would be equivalent to a 0.02, or that would be a 2% scale factor that we're dealing with here from the original truck. On the diagram, again, this is enlarged, but again, just assume that this is an 8 centimeter length here on the side of the pickup truck. The width of the pickup truck in the diagram is 3.2 centimeters. We've actually been given the actual length of the truck, which is 4 meters. That's the actual length of the truck. And again, if I took 8 centimeters and put it on top of 4, if I converted this, this would essentially be in centimeters, that would be 400. This would be 8/400, which if you reduce it down is going to reduce down to 1/50, right? 8 centimeters, and then it'd be 400 centimeters in 4 meters. So it'd be 8/400, which is equivalent to 1/50. So that's an actual, an accurate representation of the actual length of the truck. There are 2 questions we'd like to answer about this before I give you your homework for tonight, and then that's it for today. First of all, and again, this is right off of the slides, so if you've got the slides in front of you, but I will read the question to you. The first question is, if the front and back wheels of the truck, of the actual truck, are 3.85 meters apart, how far apart should the wheels be on the scale diagram? So we realize that essentially 4 meters is going to be represented by 8 centimeters. What we're asking for is basically, if I was drawing where the wheels are, and this would be sort of, the wheels would be roughly here somewhere, right? I mean, you have to put those wheels somewhere. The center of the wheels would be roughly there. The question is, if the wheels are actually 3.85 meters apart from each other on the actual truck, if we're using the scale of 1 to 50, how far apart are they going to be on the actual diagram of the truck? So if you think you can do it, give it a shot. See if you can. We're using ratios here, so this might be something you can actually kind of try at home on your own if you want to give it a shot. Remember that, again, 8 centimeters is equal to 400 centimeters on the truck, because again, 400 centimeters would be equal to 4 meters. So what we're asking for now is we're looking for a distance on the truck of 3.85 meters. So maybe we're going to try something like this. Maybe we're going to try using 8/400 would be equal to x over 385 centimeters, which would represent the 3.85 meters. Giving you a pretty big hint with that, but give that a shot. See if you can do some cross multiplication on that one and see if you can actually solve for x on that equation. And just pause me for a second if you need to, and I'm going to come back here with your answer right away. All right, now I can do it that way, and that will give me the right answer, or I can do it another way. I can basically take my 385 centimeters and I can just times it by 1/50. I could do it that way as well. Both of these are going to give me essentially the same answer. And when I plug it in, what you should be getting is a value for here. Up here, if you calculated it up here, what you're going to wind up with an x value up here is going to be 7.7. That's what you're going to get for a value of x above 385. So 8 is to 400, as 7.7 is to 385. How did I do that? It's going to be 385. You're going to multiply that by 8, and then you're going to divide by 400 to get x. Just some cross multiplication. Cross multiplication in this unit is going to be huge if you're calculating scale factors. Cross multiplication is going to be a saving grace for you in this unit if you're comfortable with cross multiplication. The other way we can do it though is we can actually plug it into either 385, or if you just use the regular, I'm going to plug this value in just to kind of show you what's going to happen. What if I just plugged in, if I have 1/50th, and if I have the wheels are 3.85 meters apart from each other on the truck, could I multiply 3.85 by 50 or 1/50th to see what happens there? Well, when I plug that number in, I'm going to get this. Now, it's going to be a different number than what you saw on the other side. You're going to see 0.077. Now, you might have already noticed that these numbers look pretty similar. Well, here's the reason why they're different. This over here, we were using centimeters. So this would be 7.7 centimeters. Because I used 3.85 here, if I would have used 385, I would have got 7.7 centimeters because I've converted my meters into centimeters already. If I didn't convert my meters into centimeters, then this value here, this 0.077, is no longer in centimeters. It's actually listed as meters. So we would be basically saying that up on this diagram, it would be 0.0077 meters apart. But that doesn't really do us any good considering that up here, we're using centimeters. So what I would do here to get this value, this 7.7 centimeters, they're the same value because I've got centimeters versus meters. All I would have to do here is just multiply by 100, and that would still be the equivalent of 7.7 centimeters. So in this case, these wheels, because they're 3.85 meters apart from each other on the truck, in the scale diagram, they would be 7.7 centimeters apart. And that kind of makes sense because 8 centimeters represents 4 meters. We're slightly shorter than that with the wheels at 3.85 meters apart as opposed to the whole length of the pickup truck. Now there's one more question I'm going to get you to work on here before we call it a day. The second question, which is in the notes right here, it's not up on the board here, but just listen to what I'm saying here. Now that I know that, I would like you to calculate the width of the truck, the actual truck. So right now we've got our 8 centimeters represents 4 meters on the side of the truck. What is the width of the truck going to be? Well, you might have noticed over here that there is a measurement, and that is actually 3.2 centimeters. See what you can do with that and see if you can calculate the actual width of the actual truck using the numbers that have been given. Pause me right now and see if you can try it out. If not, I'm going to come back with the answer here right away. All right. So here's the answer. We know that the width here is 3.2 centimeters on the diagram. We know that this is a scaled down diagram that is 1/50th of the original length of the truck. So that's scaled down to 1/50. So if I multiplied this by 50/1, I'm now going to get the actual, the scale up version of the original. Like I know that the original is 50 times larger than the diagram here, which is at 3.2 centimeters. So if I multiply 3.2 by 50, I'm going to get 160 centimeters. Again, that doesn't do me much good if it's a truck because we're not going to measure a truck at 160 centimeters. So if I divide by 100, I'm going to get that converted to meters, which is going to be 1.6 meters. So 1.6 meters is going to be the actual size or the width of the truck. Is there another way that I could do that? Well, yeah, there is. I could also use the 1/50 ratio is equivalent to, in this case, the 1 represents my 3.2, and I'm trying to solve for x at the bottom. So I'm pretty much doing the same thing I did over here, but here I'm just using that cross multiplication. And I'm going to be honest, myself, I really do like the cross multiplication way of doing things because it gives me a good way to visualize what the relationship is, what the ratio is between the two sizes. So in this case, I would multiply 3.2 times 50. That's still going to give me 160. Divided by 1 is going to be my value for x. So I'm still going to wind up with 160. But remember, These units were originally in centimeters. If I want to convert them to meters on the truck, let's divide by 100. That's still going to give me a value of 1.6 meters for the width of the truck. There you go. That's basically reductions using scale in reduction calculations. Your homework for tonight. Before the homework, again, if you have any questions about any things that you're still stuck with, give this video up here a watch. It's going to give you a recap on using scale factor for reductions. Give that a view if you need to. And if not, you can go right on to the homework. Tonight's homework is going to be practice questions 4, 5, 6, 7, 8, 10, 11, 14, and 19. And for question 19, assume that each grid block represents a dimension of 50 times 50 centimeters. So basically, if you've got your grid in the question, so here's my grid, right? Each grid block here, one of those little grid blocks, is going to represent a measurement of 50 centimeters by 50 centimeters to answer that question. All of those questions are going to be found on pages 329 to 331 of the Math Makes Sense 9 textbook. That's it for today. Won't you join me next time when I discuss similar polygons, which is going to be topic 7.3. Until then, have yourselves a great day, and we will talk to you soon.